All right, so in problem 56, we are trying to prove angle 3 is congruent to angle 4. And if you look down at statement 5, it gives you a little hint of where we have to go with this problem. If you look at it, it says triangle TMP is congruent to, and if you look at where triangle TMP is located, TMP is right here. And so that gives me a hint that if we try to get triangle TMP congruent to this triangle here, then what we'll be able to say is that this side is congruent to this side, which would then make angles 3 and 4 base angles of an isosceles triangle, and we would be able to say that they're congruent. So before I begin, I'm going to kind of just look at what's given to me, look and see if there's any hints given in the statements like there was in statement 5, and kind of do a plan in my head for that. So let me go ahead and erase this and let me get started. And if we start with the given information, we're going to say that angle 1 is congruent to angle 2. And that is given. Can't draw anything else from that, so I'm going to move on to the next piece of information, which is to say that segment TP is congruent to segment RA. And that was given also. And so I'm going to mark that off. I can't really draw anything from that, but what I can say is that if I look here, that I see that I have vertical angles. And so in my next sec, I'm going to say that angle TMP and angle RMA are vertical angles, and that's just a definition of vertical angles. And then I'm going to go one step further in step 4 and say that angle TMP is congruent to angle RMA, and that is by the vertical angle theorem. And so now I can say that I have this congruent to that. And if we look at what we have there, we have a angle and angle and a side. And so what we're going to be able to say in the next step is that triangle TMP is congruent to triangle RMA, and that is by angle, angle, side. And then the next thing we can do is we can look here at these sides and say that this side here, TM, is congruent to this side here. And that's going to be because the corresponding parts of congruent triangles are congruent. And so that would be, the segment is TM congruent to the segment is RM. And now if we look at that, if those two sides are congruent, then that would be an isosceles triangle, and that would be enough information to say that angle 3 is congruent to angle 4, and that would be that two congruent sides of a triangle implies that the base angles are congruent. If we take a look at this last one here, we are asked to be able to prove that that triangle ADC is isosceles. And so if we're looking for that, we know what we need to do. We either need congruent sides or we need base angles to be able to make that happen. And you can see that it gives us a little bit of an indication here of that we need to get the triangles congruent first. So let's try that by starting with our given information. So the first thing is that segment BD bisects triangle ADC, and that is given. And then from that, what we can say is that angle 1 is congruent to angle 2. And that's just the definition of an angle bisector. And so we have angle 1 congruent to angle 2. Nothing else that we can really use that given information to draw any more statements out. So I'm going to go to the next given statement, which would be able to say that segment DB is perpendicular to segment AC, and that is given. Now, once we know that that is perpendicular, then we know that angle 3 and angle 4 are right angles. And that is just because we know the definition of perpendicular. And then we can go one step further with those right angles, and we know that if they're right angles, they have to be congruent. And so angle 3 is congruent to angle 4, and all right angles are congruent. So we have 3 to 4. That's all that we can draw from that information that was given to us. But if we look, we have a side in here that is shared. So we can say that segment DB is congruent to segment DB, and that is the reflexive property. And once we do that, you can see that we have an angle, we have a side, and we have an angle. And so we're going to be able to say that angle ADB is congruent to angle CDB, and that's by angle side angle. And then if we know that, we now can say that segment AD, which is this right here, is congruent to segment CD, and that is going to be because of the corresponding parts of congruent triangles are congruent. And once we have that, we now know, we have enough information now to be able to say that triangle ADC is isosceles. And the reason why that is, it's a definition of isosceles triangle. If we have these two sides that are congruent to one another, then that's our definition of an isosceles triangle.